The tools and techniques of identifying risks. As per the project management body of knowledge, there are 6 tools and techniques. However, I am covering 14 of them in this lecture. Expert judgment, the most frequently project management technique or tool. Expertise should be considered from individuals or groups with specialized knowledge of similar projects or business areas. So as part of the organization, you need to make use of any experts who can add value to the risk identification workshops. Such experts should be identified by the project manager and invited to consider all aspects of individual project risks as well as sources of overall project risk based on their previous experience and areas of expertise. The expert's bias should be taken into account in this process. So the expert judgment can be used as a standalone tool for this process, or you can use expert judgment with other tools I'm covering in this lecture, like the focus groups or the interviews or the meetings. You need to conduct interviews and focus groups with experts when it comes to risk management. Data gathering techniques that can be used in this process, starting with the most popular one, the brainstorming sessions. The goal of a brainstorming session is to obtain a comprehensive list of individual project risks and sources of the overall project risk. And the key advantage of using a brainstorming technique is that you can gather a lot of ideas in a very short period of time. The project team usually performs brainstorming, often with a multidisciplinary set of experts who are not part of the team. So it's preferred to include multiple perspectives. It's a key critical success factor for the identify risks process. So invite the right participants to the brainstorming session. Ideas are generated under the guidance of the session facilitator, either in a free-form brainstorming session or one that uses more structured techniques. Categories of risk, such as the ones shown in the risk breakdown structure, can be used as a framework for this technique. Particular attention should be paid to ensuring that risks identified through brainstorming are clearly described, since the technique can result in ideas that are not fully formed. So the quick win of starting a risk identification activity in your project with a brainstorming session is that you can generate a long list of risks within a very short period of time. The second data gathering technique is using a checklist, and usually checklists are being used as a reminder. It's a list of items, actions, or points to be considered. It's often used as a reminder. Risk checklists are developed based on historical information and knowledge that has been accumulated from similar projects and from other sources of information. So usually, by checking your organizational process assets, you can find some useful risk checklists. They can be an effective way to capture lessons learned from similar completed projects, listing specific individual project risks that have occurred previously and that may be relevant to your project. So checklists cannot be used as a standalone technique or tool. It is usually used as a reminder. The organization may maintain a risk checklist based on its own completed projects, or may use generic risk checklists from the industry. While a checklist may be quick and simple to use, it's impossible to build an exhaustive one, and care should be taken to ensure that checklist is not used to avoid the effort of proper risk identification. That means that you cannot rely only on a risk checklist. It can be used only as a reminder. The project team should also explore items that do not appear on the checklist. Additionally, the checklist should be reviewed from time to time to update new information, as well as remove or archive obsolete information. This is part of a risk checklist covering the technical risk and the subcategories of a technical risk and example risks. So by looking at a comprehensive checklist or a long checklist, it can be used as a reminder to make sure that you covered these risks and to check if these risks are applicable to your project. Interviews is another data gathering technique. Individual project risks and sources of overall project risk that can be identified by interviewing experienced project participants, stakeholders, and subject matter experts. Interviews should be conducted in an environment of trust and confidentiality in order to encourage honest and unbiased contributions. So you can identify the experts in your organization as part of the expert judgment technique and conduct interviews as part of the data gathering technique. The secret of a successful interview is to give the environment of trust and confidentiality for the participants that are being interviewed. Data analysis techniques can be very useful after applying the data gathering techniques, starting with the root cause analysis. It's typically used to discover the underlying causes that lead to a problem and develop preventive action. So usually we apply the root cause analysis in risks and defects management in order to identify or determine the underlying cause and develop accordingly preventive actions. It can be used to identify threats by starting with a problem statement. For example, the project might be delayed or over budget, and exploring which threats might result in that problem occurring. So this is how you will apply the root cause analysis to identify the project threats. The same technique can be used to find opportunities by starting with a benefit statement. For example, early delivery of something you are procuring or under budget, and exploring which opportunities might result in that benefit being realized. So root cause analysis is a data analysis technique that can be used to identify threats or opportunities. Here is an example of using the root cause analysis technique. The problem statement is ignoring phase entry prerequisites. The causes might be incomplete requirements or incorrect reports, and you will dig deep, and the sub-causes of incorrect reports might be repeated audits or might be mistrust. The sub-causes for incomplete requirements might be rework, extra costs, schedule slips, or low morale. And you can dig deeper and have another level of sub-causes. Assumption and constraint analysis. Every project and its project management plan that are conceived and developed based on a set of assumptions and within a series of constraints. These are often already incorporated in the scope baseline and project estimates. Usually the project assumptions or constraints are part of the scope baseline, which is a component of the project management plan. Now, analyzing these assumptions and constraints will explore the validity of assumptions and constraints in order to determine which pose a risk to the project. Threats may be identified from the inaccuracy, instability, inconsistency, or incompleteness of assumptions. Constraints may give rise to opportunities through removing or relaxing a limiting factor that affects the execution of a project or process. So assumptions are things that you assume they will be valid and they will be true. Examining those assumptions and constraints usually release the potential risks in the project. If an assumption which you assumed earlier that it is valid, you discovered later on that it's not valid anymore, so this is a threat for your project. SWOT analysis, a technique that's frequently used in strategic management and in risk identification as well. This technique examines the project from each of the strengths, weaknesses, opportunities, and threats. This is why it's known as the SWOT. S for strengths, W for weaknesses, O for opportunities, and T for threats. For risk identification, it is used to increase the breadth of identified risks by including internally generated risks. The technique usually starts with the identification of strengths and weaknesses of the organization, focusing on either the project, organization, or the business area in general. SWOT analysis then identifies any opportunities for the project that may arise from the strengths you identified and any threats that can be a result of the weaknesses you identified. The analysis also examines the degree to which organizational strengths may offset threats and determines if weaknesses might hinder the opportunities. So we usually start by identifying the strengths and weaknesses and then analyze those strengths and weaknesses to identify threats and opportunities for the project. Here is an example of implementing the SWOT analysis on your project. You can identify the strengths and then determine the potential opportunities from those strengths, and then identify the weaknesses and determine the potential threats. Document analysis. It's a data analysis technique that is very useful in risks identification, as risks might be identified from a structured review of the project documents. Such documents includes plans, assumptions, constraints, previous project files, contracts, agreements, and technical documentation. Uncertainty or ambiguity in project documents, as well as inconsistencies within a document or between different documents, may be indicators of risk on the project. So you just need to provide a structured review of the existing project documents and determine the potential risks. Interpersonal and team skills that can be used in the risks identification process includes facilitation. Facilitation improves the effectiveness of many of the techniques used to identify individual project risks and sources of the overall project risk. A skilled facilitator can help participants remain focused on the risk identification task, follow the method associated with the technique accurately, ensure clear risk descriptions, identify and overcome sources of bias, and resolve any disagreements that may arise. So having a skilled facilitator while conducting sessions like the brainstorming or the interviews or the meetings will increase the efficiency of those sessions. Prompt lists are tools used in the risks identification process, and the prompt list can be defined as a predetermined list of risk categories that might give rise to individual project risks and that could also act as sources of overall project risk. So it's a predetermined list of risk categories. The prompt list can be used as a framework to aid the project team in idea generation when using risk identification techniques. The risk categories in the lowest level of the risk breakdown structure can be used as a prompt list for individual project risks. So you can consider the risk breakdown structure or the lowest level of this RBS as a prompt list and revisit all the categories in the risk breakdown structure to identify individual project risks. Some common strategic frameworks are more suitable for identifying sources of overall project risk. For example, one of the most popular ones is the PISTL. P refers for political category, E for economic, S for social, T for technological, L for legal, and E for environmental. TCOP is another prompt list, T for technical, E for environmental, C for commercial, O for operational, and P for political or VUCA, V for volatility, U for uncertainty, C for complexity, and A for ambiguity. These are examples of prompt lists, and here is the PISTL prompt list listing the key risk categories under each of these letters or main categories. Like looking at the environmental, you have the weather, the climate, the policies, the climate change, the pressures from NGOs, and so on. So by looking at such prompt lists, you can identify additional risks for your projects. The meetings are useful when it comes to risk identification. The project team may conduct a specialized meeting, and usually they are known as risk workshops. Most risk workshops include some form of brainstorming sessions, but other risk identification techniques might be included also depending on the level of the risk process defined in risk management plan. Use of a skilled facilitator will increase the effectiveness of the meeting. This is why the facilitation is an important tool of this process. It's also essential to ensure that the right people are the participants of the risk workshop. On larger projects, it may be appropriate to invite the project sponsor, subject matter experts, sellers, representatives of the customer, or the project stakeholders. Risk workshops for smaller projects may be restricted to a subset of the project team. Data representation tools and techniques that can be used as part of the risk identification process includes the cause and effect diagram, known as the Ishikawa diagram or the fishbone diagram. It's similar to the root cause analysis technique, but it presents in diagrammatic form the causes with the contribute to given outcome. Each cause can be split further into sub-causes. The diagram then identifies risks as those uncertain events which could result in occurrence of the impact. To use the Ishikawa diagram for risk identification, the outcome should be stated as an effect on the project objective. It should impact one of the project objectives. The diagram then identifies risks as those uncertain events which could result in occurrence of the impact. This technique usage for risk identification can lead to confusion between risks and issues. Keep in mind that a risk is an uncertain cause of the impact. It's something we are not sure it will happen. While the issue, it's a certain cause of the impact. Here is an example of the cause and effect diagram, or the fishbone diagram. So the stuff is leaving is the main outcome. The key causes might include environmental causes, ambition, career prospects, remuneration or satisfaction, and you can then dig deep into the sub causes. Like, for example, the satisfaction might include the variety, the challenges, and the recognition. So this is an example of the fishbone diagram. Influence diagrams also are tools used in risks identification. It can be defined as a diagrammatic representation of a project situation, showing the main entities, the decision points, uncertainties, and outcomes, and indicating the relationships or the influences between them. The influence diagram can identify risks when combined with sensitivity analysis or Monte Carlo simulation to reveal sources of risk within a project. Sensitivity analysis and Monte Carlo simulation are techniques used in the quantitative risk analysis process, and we will be covering later on in this course. Here is an example of an influence diagram showing a situation of bidding or selecting the best bid. Here are the entities, the decision points, and the relationships or the influences between those entities. System dynamics, it's similar to the influence diagrams. It's a particular application of influence diagrams which can be used to identify risks with a project or within a project situation. The system dynamics model represents entities and information flows within a project. The results of the system dynamics analysis can show the impact of risk events on overall project results, such as the cost or schedule results to be expected. It's an advanced risk identification technique, but you should expect one question in the exam about the influence diagrams or the system dynamics. Analysis of changes in the model or assumptions can indicate the system sensitivity to specific events, some of which may be risks. Here is an example of the system dynamics. It's similar to the influence diagram. It's used to identify risks within a specific project situation. Force field analysis is another technique that can be used in this process, typically used in the change management context. It's adapted for risk identification by identifying driving forces for changes, and the restraining forces that are forces against changes which currently affect the project objectives. So you can use the force field analysis, which is commonly used in the change management context, in order to identify risks by identifying forces for changes and forces against changes. Then risks can be identified as uncertain events or conditions which would lead to change in the strength of one or more of the identified forces. So here is an example of applying the force field analysis. You can identify or determine the forces that will drive the change and the forces that will be against the change. And then risks can be identified by looking at the uncertain events which would lead to a change in the strength of one or more of these identified forces. Failure mode effect analysis, it's also known as the fault tree analysis, can be defined as a methodology for analyzing potential reliability problems early in the development cycle, as it is easier to take actions in order to overcome these issues. It's used to assess the potential reliability of the product. So, failure mode effect analysis looks at the potential failure modes of the system or the product, determine the effect on the operation of product, then identify solutions to mitigate those failure modes. The best time to apply the fault tree analysis technique is in the earlier stage It was used by engineers in order to improve quality and reliability of the design of the product or the system. Here, as we are focusing on project and risk management, we will consider usage of this technique in identifying risk and creating the risk register. Once the team is done with listing all the failure modes, which is the first step of applying this technique, failure mode effect analysis will rate the different risks associated with each failure mode. Failure modes with the highest ranking are handled and documented in the risk management process as risks. Highest ranking here is described with their risk priority number, which we'll be explaining later on, but here is an example of applying the failure mode effect analysis. For the exam, you just need to understand the high-level description of the failure mode effect analysis and how it's going to serve you while identifying the project risks. Conduct a pre-mortem. It's a very simple technique. It's a meeting to come up with ideas. This is a pre-mortem. The assembled group is then asked to imagine that the project is completed or has been terminated. It has failed to meet one or more of its objectives. So you will gather the team members and you will ask them to imagine that the group was a failure or it was terminated. After that, the group is asked to describe why the project has failed. The same shall be repeated while imagining the project is a success in order to find the opportunities. So the team will imagine the project was a failure and they will start thinking about the reasons of this failure, and these reasons will be the threats, or the team that will be asked to imagine that the project was a great success and the possible reasons for this success might be the project opportunities. Affinity diagrams are tools that is frequently used in risks identification, and the trick of using this technique is to look for missing categories using affinity diagrams. So for the exam, keep in mind that affinity diagrams and checklists are commonly used as a reminders for the risk identification activities. In this technique, the ideas generated from any risk gathering techniques are sorted into groups by similarities. Each group is then given a title. This title is the similarity between those risks. This sorting makes it easier to see additional risks that have not been identified. So by gathering the ideas or the risks you identified earlier into similarities, categories of similarities, by looking at these categories or at the affinities, you can determine any missing risks. Here is an example of the affinity diagram where you categorize the risks based on change obstacles, planning, or implementation. By looking at an affinity diagram, you can determine the risks which you missed. The risk breakdown structure, or the RBS, which we explained earlier in the risk management plan, it's a tool used in this process. It's a hierarchical framework of potential responses of risk to a project. An organization can develop a generic risk breakdown structure for use across all its projects, or a project may use a project-specific risk breakdown structure. It contains usually levels 0, 1, and 2, and so on, categorizing each group of risks in the first level. So here is a screenshot of the risk breakdown structure. The level 0 is the all sources of project risks. Level 1 is management risk or commercial risk. And then you will go to level 2 where the individual project risks. Here are some major items which you should be aware of regarding the risk breakdown structure, or the RBS. It serves as more than just a database for identifying risks to the project. It provides a vehicle for risk analysis and reporting and risk comparison across the projects. Most importantly, the risk breakdown structure is the tool for risk identification. So don't deal with it only as a risk database. When you sit with the team to identify risks, the risk breakdown structure might be very useful. Categories could serve as a great reminder, especially in a brainstorming session. So the RBS can be used with meetings, interviews, or brainstorming sessions. RBS is just one way to categorize risks. It's not a tool or technique by itself, and it should be included as a part of the risk management plan, and we explained this earlier. It's a section of the risk management plan. Once you come up with a list of risks, you will label each risk with one of those categories, since that will make it easier to figure out how to deal with risks later. So here are some tips of dealing with the risk breakdown structure. Critical path is an important tool used in risks identification, and I am covering this topic in detail as part of the Focus on Math section. The critical path in schedule management knowledge area is defined as the longest sequence of activities in a project plan which must be completed on time for the project to complete on a due date. Now, why it's a potential source of risk? Because any activity on the critical path is more risky than others since it have zero float. Float is the buffer each activity can have. For example, if activity A has a float of 7 days, that means that even activity A was delayed by 6 days, for example, this will not impact anything in the project. This is the float. All the activities located on the critical path have zero float. This is why they are risky. Any delay of this activity will delay the project itself. So as a professional project manager, you should give attention for the activities that are in the critical path or the activities that are not on the critical path but have a small float, since any problem on these activities will easily make the activity on the critical path. The Delphi technique is one of the most important techniques usually used in project management. The key advantage of applying this technique is that it prevents any type of bias. Usually it's used in the collect requirements process or as part of the risks identification process. In brief, it's a request for information usually sent to the experts who are participating in this session anonymously. The responses are compiled. The results are sent back to the experts for further review until they reach agreement, but they will participate on an anonymous basis. It's a group decision-making technique in risk management. It can be used to obtain consensus of expert opinion on what work should be performed and what risks exist on the project. So Delphi technique is about reaching consensus from experts' opinion on an anonymous basis.